And then, so Victor will move to next Tuesday. Today we will do Nadia, Ibrahim, and Nihal. Right? Okay, looking forward to listen to you guys. I think that this is fun. I think that and I know Ilya is not available. He will come later. He sent us a note about this. Okay, Nadia, you.
May I also have a question?
Yes.
Sorry for interruption. I couldn't participate, unfortunately, in the previous lecture, and I would like to ask if there is evaluation form which was used previously and probably will use also today. Could you please resend the link if it is the same?
Yes, yes, yes. Okay.
Oh, I don't know.
No problem.
Thank you.
Okay, Nadia, we're listening to you.
Okay, thank you very much. Hello to everybody again. Do you see my screen okay?
Yes, we see it well.
Okay, as you already know, that my research is about intellectual property and international pathways for appropriating value from endogenous technological innovations. This is a reference model which you have seen last time, and as you mentioned and noticed, it's very big and very broad. But do you see my cursor? Yes?
No.
Cursor? No. Okay.
No, I don't see it myself. Anybody else sees it? Now we have it.
And now? Now,
Yes.
okay, let's work in this mode. But on this reference model, I tried to put a whole picture which I catched from the literature. But I plan to work on a gap when different authors mention that patenting matters in national economy, it matters on innovations, it matters in development of economies, but all different types of patenting mixed up together. And in my research, I may focus on outward bound but international patenting activity influence on national economy. Deeper literature review allows us to split different modes of patenting in 3 ways. And in the first paper, which we now have under review with Kelvin Willoughby, we describe 3 modes of patenting. It's when national residence patent in home country, when foreign researchers patent in some countries. Let's use Russia as example, when foreign researchers patent in Russia, but we're interested in this third mode when Russian researchers patent abroad. And this is less described in literature, and moreover, authors describe causes which leads to outward bound international patenting, but we're focused on which effects do they have, which economic effects we have from outward bound patenting. And we proved that outward bound patenting matters. We developed 2 indexes, and the most important one is international patenting activity density. And we split countries into 4 income groups: high, upper, middle, and low income. We didn't show low income group because it's very chaotic on this picture, but we see that over 18 years, outward bound international patenting activity in the whole world increased. And what is more interesting is that upper middle income countries like Russia, India, Belarus are stagnating in outward bound international patenting. But we proved with regression analysis that it still matters. Of course, it has small influence on national economies, but it has. Thus, we split all countries in the world in 4 categories: innovators, inventors, slow movers, and traders, according to their changes over 18 years in national wealth and in outward bound international patenting activity. Also, we described that the most flow of outward bound international patenting goes from rich countries to upper middle income countries, and vice versa, and others flows more weak, but it is. From this point, I state my research question: what is the exact mechanism of appropriating benefits from outward bound international patenting activity in the national economy wealth? And my proposition is that countries which are active in international patenting, and I state 2 hypotheses: that countries ship either knowledge-intensive experts abroad, either they're involved in technological transfer via commercialization of licenses. And the main theory, which I try to support in my project, that outward bound international patenting activity influence on national wealth positively. And I plan that my impact model is like this. We have already proved that technological competitiveness on global market influence on national economy, and we proved it with, as you just seen, with regression models when IPAD is our index of patenting activity, influence on GDP. But I also would like to describe that quality of national innovation ecosystem, strong national innovation ecosystem leads to less limitations of development of technologies, and I created index, International Technology Specialization Index. And as less limitations we have, as stronger we have development of endogenous technological innovations, and I measure it with International IP Portfolio Complexity Index. It's also index which I developed. These 2 indexes I developed according to another economic study, another economic theory about I'll show it later, theory of economic complexity, but I applied it to patenting analysis sphere. And development of endogenous technological innovations influence on technological competitiveness on global market, and it influences on licensing and on export, and then it influence of national economy. The next step is that the mechanism which I would like to describe. I mentioned reasons which could be influenced by international patenting, and this is export, this is licensing, and also there are some other reasons, but I don't plan to describe them deeply. And this is money flows to national economy, why export and licensing goes back as taxes and salaries for national economy. Nobody in literature before connected international patenting and GDP. Some authors describe that outward bound international patenting influence of knowledge-intensive expert, and of course, some authors describe that knowledge-intensive expert influence of national economy, but nobody connected all together. And now I just finished this paper, and I compare, this is, I can call main body of my research. I can compare patent flows from one country to other countries, outward bound patents, and knowledge intensive export flows. And the first hypothesis is that if technologies mentioned in patents match with export products, then countries protect export on importer territories. And the second question is, if destinations of patents and destinations of knowledge-intensive export match, then patents used exactly for protecting physical products on the territory of importer. It has long research methodology because I compare 4 types of classifications. Sometimes I use ready concordance table, sometimes I create these concordance tables by myself. And I have results like this on example of aerospace expert products. I would like to demonstrate you how these types of products match with technologies and pattern classifications. For example, helicopters, spacecrafts, and propellers and rotors and parts thereof match with transport. It's all of this already classification. I didn't create it by myself. You can look sources if you're interested with transport, and it's connected with mechanical engineering, and also what I can say, for example, directions of finding composites links with engine pumps, turbines, and instruments, and also measurement instruments and mechanical engineering, and so on. I can't say right now how many products, and I have 36 technologies, but how many products? A lot, 400 products. And the results is like this. I also split all countries in the world, 200 countries over 18 years, into 3 groups: innovators, inventors, and traders. Innovators, which proved both two hypotheses. They use patents to protect the knowledge-intensive export products on the territory of importer. Inventors, which have a knowledge-intensive export and have outward-bound patents, but they not match on the same direction. And traders, it's other world. And it can work like this approach for market analysis and technology landscape. Actually, it's a new approach for technology landscaping. I showed on the example of Japan. When we know which export products is the most attractive for Japan, we know which technology is the most attractive, and we can make different kind of analytics. Also, I plan to describe licensing approach in the same manner, but I didn't do it yet. That is why it's just like labels that licensing will be here later. And the third part in my research is historical limitations of endogenous technological innovations. Which limitations influence why countries use one or another strategy, why they decided to use export strategy, or they have only wait for commercialization. And I make assumptions that it's because of either capabilities of countries. Do they have capabilities to produce something? Do they have knowledge capabilities in the researchers to do something or not? And I can make brief conclusions that some countries have different capabilities and limitations. And if it goes to companies level, different types of companies could have different limitations. For example, universities don't have opportunity to produce, for example, export products in big amounts, and IT companies don't need to do it. But that companies who can produce, they of course could do it. Exactly this is described on this table. And this brings us to the theory of complexities that I decided to measure level of development of endogenous technological innovations with IP complexity portfolio for each country. Complexity, according to this theory, I use the theory of Hausman and Hidalgo for economic, that complexity based on specialization of the country and the ubiquity of technology. In other words, how many technologies are in the patent portfolio of the country and how many countries work on the technology. And this is like a map with connections that, for example, Germany are professional in engines, pumps and turbines, transport and mechanical elements. Specialization of Germany is 24. It means that Germany is specialized globally on 24 technologies, and 137 countries from 200 patent abroad and giants, pumps and turbines a lot, and so on. Then I describe index, which is based on discrete matrices of index, which I described earlier, and so and go on and further. And finally, this is index which will measure IP complexity portfolio of different countries. If this index is high, more than one, it means that endogenous technologies are applied in a range of export products, and if it's less than one, then it means that countries specialized on very few technologies which are applied on export products. How all of this could be practically applied? It leads to some decision-making process. Maybe it will be software, or maybe it will be like methodology for the decision-making approach for international strategy for patenting. Companies could make could follow this methodology for technological landscape, for patenting landscape, and make chosen where they need to patent broadly and where market is, for example, full, or vice versa, demand on their products and where they can make the international business. That's all. I just forget, I have one more idea on this slide, but maybe I'll remember it later. Thank you very much for your patience. I'm happy to answer your questions.
Okay. Questions, please. Comments.
Do you feel yourself now professional of international patenting strategies?
No.
No, sorry.
No. It takes time, like any topic. Well, maybe other people will say yes, but for me, no.
Okay.
May I have a question?
Yeah, sure.
Nadezhda, thank you for interesting and just amazing presentation. I just would like to ask about this country's income data you presented, and you also categorized for inventors, innovators, and other two categories. Yeah, there's no more.
Oh, we're missing. Elena,
I'm sorry. I just sent a message to her that.
How you received this data somehow, or you use?
About income groups, yes?
Yeah, yes, about income
yes,
groups.
Yes, oh,
data. So you calculated it.
It's very easy. No, I didn't calculate it by myself. It's open data, and we use such resource as World Bank of Data and their methodology, and they suggest this classification of income. I'll send you a link to this.
Thank you so much. Thanks.
Yeah, I just remembered what I forget to tell. Why this approach is new in scholar in science, because it's product oriented. Usually when we have patent analytics for creating technology landscape and so on, we speak in terms of patents. We speak in terms of patenting law on codes of patents. But this approach suggests product-oriented language. That is why we can speak in terms of product, which company suggests to market, and then we transfer it to technology-based analysis.
Thank you very much.
Yeah, Nadia, did I understand correctly that you're focusing on aerospace or?
No. I work now. I haven't for this moment. I have a specialization on specific technology and specific range of products. I just suggested to show you this range because it's closer, by my opinion, to most of listeners on our course.
Okay. Did you go back to hypothesis and research question?
That's it.
You see, I think research question is very good. Proposition, countries which are active in international patenting succeed in international trade. I think that's an hypothesis. And what you show an hypothesis, I'm not hypothesis. I don't think so, but I think your proposition is an hypothesis. Countries which are active in international patenting succeed in international trade. Is that not? Did you agree that this is an hypothesis?
It could be transferred. And do you think that my hypothesis could be called like methodology? Yes.
Yeah. So it could be classification of cases, or I don't know what, because it seemed to be, because they're not hypotheses. Countries ship non-intensive export abroad. That's a fact, right? It's important facts, or I don't know what you.
Okay, thank you for your opinion, because I have found this template also for PhD's projects and try to use it.
Well,
okay.
Where did you find this? Where did you find this is a question.
I'll send you also source.
Okay. The purpose of the course is to be able to, because anything that's published is not necessarily right?
Okay.
So it's good to look at this and say, okay, now what because it's all mixed, even the theory, outward bound international patenting activity influence on wealth, that seems to be an hypothesis also. To me, it's not a theory. A theory would be that indexes we can quantify, or the methodology, statistical inference can allow us to measure these, or something like this. Theory. Mix up
okay, thank you very much.
There and other things and facts. And can you go to your reference model? I'm wondering, I think this arrow at the bottom, I see now, this is a different, so you see that the national economy influences the strength of national patent protection system. I thought this arrow here at the bottom, right?
This one.
National patent protection should be in the other direction.
Vice versa.
Should it be in the other direction? I think it should. That's what you're trying to prove, no?
Yeah, it's what I would like to prove. I would like to prove that the system works via outward bound patents and export, and then goes back to national economy in positive
My question
way.
is very specific here, Nadia. Is Park and Ginnar, as a paper from 1997, did they really show that the national economy influences the strength of the national protection system? Is that what they say in their paper?
Yes.
Probably the
they
most.
said they said that rich countries usually have a strong patent protection system. That is why they are attractive for foreign researchers to protect their inventions on their territories.
Okay.
It is.
But shouldn't it be bi-directional? Nadia, should it be bi-directional?
Again, I think that vice direction could be explained via big mechanism. how this strengths of national patent protection system influence back on national economy. Of course, it comes back with rich countries becomes richer via whole this process that they attract foreign researchers, they attract business from other countries. That is why they attract more money from the world to their territories. That is why all of them pays taxes, salaries to them. That is why they become richer.
Okay. Do you have the impact model? Did you do the impact model? I don't remember seeing it. Okay. And where is your lozenge? Where is your contribution?
My contribution is that I proved that this mechanism is really work, and also this is my which I call proposition, but we just call it a hypothesis, that those countries who are strong in patenting activity succeed, because also in literature, I just explored another gap that a lot of researchers mentioned. Then countries are active in export and licensing. That is why they're strong in international trade activities. That is why they become richer. But my hypothesis is that they need be active on outward bound patenting activity to influence, to be able to make successful international trade.
But what I understand here, you didn't put a lozenge because you don't think you will have a tool or a specific methodology that will be useful later. Why didn't you put lozenge?
Can you repeat, please? I didn't.
Because the impact model has to have, you see, there's the hexagon, which has the concrete contribution. And when I'm looking for the concrete contribution of your work, will your work at the end have a methodology or a tool which is going to be able to measure the technological competitiveness on the global market?
Yes, it will be contribution. I don't know how to show it. I don't know yet how to show it on impact model, because I assume that my contribution on impact model, I can show it in comparison with the reference model. That on reference model, strong international trade here after licensing and export. But on my impact model, it's before licensing and export. This is how I can show. But of course, major its contribution to its scientific contribution. But practical contribution, yes, it's new methodology for market analysis and the decision-making process of international strategy for patenting.
Okay. Okay, but I think there is, I'm sure that you have I think that you should have a tool or a new methodology at the end that will be your measure. Hexagon, I'm sure in your document that you will write there that you need this identify, and the sooner you identify this, Nadia, the better you will be, because the stronger your defense will be, the stronger your thesis will be, because now it's clear. Because now it's kind of the way the impact model is that, okay, I guess it's the dark arrow that we identify, we prove that technological competitiveness on the global market, okay, has an influence on national economy. So this is, in fact, I thought that, because what I'm surprised here, that in your impact model, there's no, I thought, well, go back to your research question. You don't mention outward bound international patenting is not there, and I'm really surprised.
Yeah, because all of these indexes are based on only outward bound international patenting. I created 1, 2, 3, 4 indexes, and all of them are based only on outward bound patenting. I don't speak about other patenting directions.
So I guess I see it's just that you don't know where to attach your contribution. Is that the way that the hexagon? It's because I would attach it myself. I think technological competitiveness on the global market. This is what you want to act. So your contribution or strong international. So you could put the hexagon, let me see, that's where I would put. Let me see, mouse. Do you see my mouse? No, eh? Let's
no.
Draw, arrow. Okay, let's see, draw. I will draw. I would put my hexagon there. And with arrows to here and to there.
Oh, okay. Thank you very much. I will think about it.
That's where I would start, because I think this is where you're trying, because you're not competitive high-tech export. I think your tool, you're trying to establish a strong, you want to build a strong international trade and find the indicators and influence this. That would be where I would put my contribution, Nadia. Could you go back to the next? Okay, some other people have some questions.
Yep.
Go ahead, Yuri.
Okay, first of all, thank you, Nadezhda, for the presentation. It was quite interesting, but I don't feel myself as professional as well. I have 2 questions and 3 questions basically. So your theory or proposition, as hypothesis, as we rename it, as I understood, it states that outward bound international patenting leads to the trade activity, which leads to the national income. But are you stated, I mean, do you state it like in general or for some specific technology? Because I believe it's valid only for some certain technologies, not for all of them.
Actually, now I work for whole technologies and whole the world, all products, all technologies, all countries. Now I'm not specified on particular technology and particular products. Where didn't still decide with Kelvin, should we specify on particular technologies or not? Maybe later, maybe here when I start to describe deeply limitations, why different countries prefer different strategies, maybe here I will be specified.
Okay, got it. And regarding the indexes that you introduced, I'm just curious how it's working. You mentioned that you developed 4 indexes. It means that such indexes are not mentioned in literature at all, like they're completely new, or you just adapted some existing indexes?
Actually, in literature present a range of indexes which try to measure different success of patenting activity, and index of international patenting activity density isn't described in literature, and we described it. It's how many outward bound patents may produce one country, divided on whole number of patents, both domestic and abroad, and normalized by worldwide data of the same. These indexes, for example, International Technology Specification Index, it's I applied methodology of revealed comparative advantage index, which were developed for export products in 1965. And still that moment in literature were described only the same index for patents for revealed technological advantage, but it still use the whole mass of patents, both domestic, outward bound, whole. And I pure this data only for outward bound patents. I measure only outward bound international technology specification, only international trade. And such index were not developed. And yeah, okay, not this index. No, but I don't know why, but nobody repeat this complexity theory. This complexity theory for technologies. It's developed for export products, for economy, complexity of economy, but it's perfectly fit to patents, patent analysis.
Okay, and you kind of 100% sure that it's not developed yet?
During 3 years, I didn't.
I see. Mm-hmm.
I have a question here, maybe Yuri. Are you finished, Yuri? Are you finished?
No, I have one small one, last one. Can you please explain what is endogenous? Endogenous,
it's which were raised in your home country. It's Russian national innovations which are applied to Russian knowledge-intensive expert, which are succeed on global market.
Thank you.
For example, raised at Skoltech.
But just why don't you include endogenous internal influence, patents internal for internal, as a comparison in your analysis? Or do you, and I missed it?
I think that I can answer in this way. We apply to this mode of patenting when, for example, Russian researchers patent abroad. That is why we call that innovations which are created by Russian researchers in Russia, it's in endogenous innovations, which are applied to export products, which are succeed on international market.
Yes,
Yeah.
I know. I know you do this, but I'm saying as a comparison of the effect.
Comparison of the effect.
I understand this. That's fine. What I'm saying is that why are you not comparing to endogenous results? How much in countries? I'm sure that maybe that's because it's done already many times. It's the influence of patenting on the internal economy. As a reference, you're talking about on the outside, I mean, outside patenting, but you're not looking at internal patenting on the internal economy.
Because thank you. Now I got because it's focus of my research, and it was described actually many times in literature, and also here most of general literature describe national patenting at home. The second place of amount of papers is that how foreign innovations influence on national market, and it is I show it here that it, for example, attract foreign direct investments, and that market of one country are attractive for other countries, companies from other countries to make businesses there. But yeah,
my question is that let's see that these studies, or if you do the analysis, that the internal to internal is 90% or 50% of the activity, and the outbound is only 10%. that would be interesting because that says, or maybe it's the opposite. I don't know. Maybe the outbound licensing and patenting is more important.
Maybe this slide also helped me to answer on your question, that here we split 18 years into two groups from 2000 to 2008 and 2009 until 2018, and it is done for 4 income groups, not for particular countries. But of course, we can see that high income countries most patent in high income countries, and upper middle countries most patent at upper middle.
Okay.
But now I think no, it don't help me to answer, because, for example, this will not show that, for example, Germany patents the most in US that at home. Oh, okay, Lemon, thank you very much. I have analytic about which you ask in comparison, who prefer domestic patenting and who prefer outward bound patents. I have this. I didn't show it.
And what are the most successful countries doing this?
Actually, the most successful country is Monaco, Netherlands, Luxembourg. It's small countries who explore in 90% outward bound patents because they don't have a national market. Very small market.
You see, that's why I think it's important to look at the internal impact and compare with the internal impact as a reference. Okay.
Okay. Thank you very much.
Any other questions or comments, please? Okay, good. Thank you.
Thank you very
Romuald, I
much.
have a comment. So, yes, thank you for the presentation, but probably I'm thinking about the format of proposal. For me, it looks like you propose like methodology, not like you propose equation and propose some solutions. So from my point of view, you mix solutions and some open questions slightly. I don't know, doesn't feel that it's strongly separated. I don't know, just my impression. Probably I'm wrong. So I just have some doubts about how this kind of presentation should be structured.
Well, yeah, I think your choice, Nadezhda, is that you decided to present results, quite a bit of results, and it's not required at the research proposal level. You kind of presented an update on your research, you see? Where research proposal, I agree with you, Victor, is that the research proposal is not so much on preliminary result to say, okay, this is the basis, this is how I arrive at my research question, but it's not about presenting update. I guess you've been working on it for a while, but I think that you need to, a research proposal doesn't need results. It needs a good research question, hypothesis, a plan, and also a time frame. You did not present to us a time frame, how long it will take to arrive at finalize your thesis, you see? So you presented kind of an update on your research and not a research proposal.
Oh, okay, thank you.
You need to be careful about this, all right?
Thank you, okay.
Any other question? Okay, thank you very much. Thank you.
Thank you.
So I think I'm next.
Yes.
Hello, everyone. Do you see the slides?
Yes.
Okay. My name is Mikhail Krim.
Oh,
Polakov. I'm the second year PhD student. Do you hear me?
Cutting off for some reason, we're losing you. I don't know why. It seems that your network connection is not good. I'm not sure. Okay, keep going, and we'll try to listen to you. If required, we'll cut our video for you, or maybe you should cut video. Try it, continue, restart. Okay.
Hello, everyone. My name is. I can reconnect from my computer because I think Wi-Fi in campus is bad.
Let's try. I don't have any problem where I am, but maybe you have problem. But keep going. It seemed to be better now. It seemed to be better. Right.
Okay. So today I'm going to tell you about my research plan and the current theme of which is unsupervised 3D feature detection for visual localization. I would like to cover some topics about motivation, problem statement, related work, reference model, research question, impact model, and research methodology. Let's start from motivation. Today, the robotics is developing in a high rate, and the market of robotics is doubled twice through the next several years. Especially logistic robotics is growing. So there is a big demand for mobile robotics. There are three main requirements for mobile robotics. The first one is a high robustness. For example, disinfection or medical robots must be very robust and perform their task with a big accuracy. The second requirement is the possibility to work on the large working areas. For example, in good case, it is maybe Moscow, but Skolkovo is also a big area, for example, for delivery robots. And the third one is the cost of robots. For example, robots for business, for logistics, is limited by the cost of current robots. For these robots, we need to estimate robot position and surrounding map to allow them to perform their tasks. There is four main perceptual tasks: odometry, localization, mapping, and SLAM. My focus of my research is localization. Robot position based on previous map. These two main approaches sensor for robot localization, camera-based and LiDAR-based. Today, LiDAR-based localization is dominant, but LiDARs are very expensive. For example, Velodyne cost $85,000, but cameras is much cheaper. Also, there is other advantages of cameras, for example, wide field of view, dense data, rich information, and also it is important that cameras are passive sensors. We need not to emit some light. We only receive information, not emit this light. So my problem of my research is improve visual localization in indoor-outdoor environment in terms of accuracy, model size, training time, and computational performance to allow mobile robot to work in long-term, large-scale, ambiguous environment. So I have 4 metrics and 3 challenges for environment. There is 2 main approaches for solving visual localization. The first one is an image-based approach. The idea of this approach is to estimate position of the robot based on a database of images, or based on neural net that regress image to position. We can say that features in image-based approaches are global image descriptors or all image. Perceptive field for this approach is a whole image. Also, this approach has a low amount of features and a high amount of information per feature. The second approach for visual localization is structure-based approach. The idea is to use structural 3D elements of the scene to represent the map. Perceptive field of this approach is image patch. Also, these methods has high amount of features and low amount information per feature. We can summarize these ideas in a reference model. We have one success factor, it is profit. It depends on robustness, size of working area, and robot cost. Also, it has 4 measurable factors: localization accuracy, training time, model size, and computational performance. And we have 3 key factors which we can adjust to optimize measurable factors. Perception field, information amount per feature, and amount of features. My main idea is to use unsupervised 3D feature detection, which allow to merge 2 approaches, image-based and structure-based. And my question is how unsupervised features detection and description can reduce model size and increase localization accuracy. And my main hypothesis is unsupervised or semi-supervised approach for 3D feature detection will allow us to increase accuracy of POSNet method with low map size of any localization method. I found that there is a research gap in literature, in current technologies, which we haven't good unsupervised 3D feature detector. We have object SLAM approach, but it uses supervised features. We need unsupervised. We have absolute post-regression method, but it also has unsupervised features by the way implicit. They stores in weights of neural net. We need to explicit 3D points, and these can allow us to increase accuracy. We have structure-based localization, but it has very big amount of features and big model size. We have unsupervised feature detection method like unsuperpoint, but it detects only 2D features. We need 3D features. And we have scene coordinate regression methods. These methods detect regress scene coordinates, but it regress dense representation and also sparse features for this. I also have many sub-questions how many 3D points should we learn, which size of receptive field should we use, and should we use variational method or we should use unsuperpoint, and other sub-questions. So to summarize this, I have impact model. In this impact model, I would like to provide 3D features which reduce this key factor, but I want to use unsupervised features thus that we not influence feature detection, precision, and recall, which allows us to increase localization accuracy and decrease model size. Currently, I am on the research qualification stage. My main methods are literature analysis and preliminary modeling and testing, preliminary testing of my hypothesis. I cover, I have 3 stages before. I work with unsupervised depth prediction, localization based on variational methods, and I trying to implement loss function based on the group for POSNet localization. Currently, I starting new stage with unsupervised 3D points, and I hope hope that this stage is will be more useful. Then I'm going to make descriptive study. I'm going to model mathematical investigation and modeling of my method in code. I'm going to use PyTorch, deep learning, and other deeper libraries. Then I'm going to test these hypotheses, these methods on the famous open source dataset standard, Simon Stand's Oxford Robot Car dataset, and also MLflow framework for parameter adjustment and experiment tracking. And the final stage is testing on the real robot. I'm going to use ROS framework and real robot to validate my hypothesis, validate my method. So let's move to conclusion. As I said before, robotics is a highly developing area. At its neat localization system, LiDARs are expensive, so we need to use visual localization. Visual localization has two main approaches, structure-based and image-based. They both have advantages and disadvantages. And my hypothesis is that 3D unsupervised feature can take best from both approaches and reduce model size and increase accuracy. Thank you for your attention. If you have any question, I will be glad for answer them.
I just have one quick question. Are you going to use stereo cameras or just one single camera?
I'm going to use one mono camera.
Okay.
Maybe then in the later stage, I will cover RGBD cameras or stereo cameras or EMU plus mono cameras.
Okay. And why not using a chip LiDAR and then working with the camera? I mean, using this chip LiDAR to better estimate the position and then use the camera to.
With LiDAR, we have problems that chip LiDAR is a 2D LiDAR. It has only one scan of environment from one height, but images has much more information about real world. We have from one image we have 4 megapixels we have million pixels, and LiDARs only have 10 or 20,000 for one instance of measurement.
Okay. Yes.
Let's go back to your research question and hypothesis. Why? Because your hypothesis is that you have, in your research question, you see how unsupervised feature detection and description can reduce model size, increase localization accuracy. Okay, fine. But then as soon as you move, and then later in your presentation, you talk about unsupervised and semi-supervised, and now we don't know anymore because your hypothesis, why in research question are you not, my two questions for you on the research question is why are you not talking about semi-supervised in your research question? And why are you talking about camera only? Because I think that it's important, right? Because if you have LiDAR, your research question could be applied to other measurement methods. Unless unsupervised feature detection is strictly for camera based. That's my question.
I mean by unsupervised feature detection and semi-supervised. In literature, there is some mess with these terms, because we can say that we have unsupervised and semi-supervised feature detection, because we have during training, we have the ground truth data for positions. We haven't ground truth data for environment. So we can say that this method is semi-supervised because it has ground truth data for position, and unsupervised method because it has not ground truth data for environment, for featured positions.
Okay.
So I think I take this point. I use then I will use consistency methodology,
Yeah,
terminology.
yeah. It's about consistency of language, right?
Yes,
And
it is my
that
fault.
you're focusing on that. And really, I thought it was accuracy from your last answer. I'm wondering if it's localization precision rather than accuracy.
I think it is most about accuracy because we don't want a systematical error. We not only optimize the noise level, but also systematical errors.
Okay.
And so
Okay.
it is more like accuracy.
Okay. Okay. So you want to find the absolute position and not the repeatability.
Yes, we need to optimize absolute position drift. It
Okay.
is the main criteria for localization. If we have visual odometry, we may be more interested in precision.
Okay. 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 All right. Any other questions or comments? Michal? Any other? So we need some, so everybody thinks that it's perfect.
When you say unsupervised, you mean that so the robot doesn't have any information about the scenario?
Yes. Yes, we have a scan. We have ground truth trajectory on this scan. And we have, their task is to train some network which can detect some interested point, but we don't know these points prior.
Okay.
For example, for visual odometry in outdoor environment, we have traffic signs or some other element of road, and some method used with element for localization, but with element are trained supervised for detection. I want to train them unsupervised based only on knowledge that we need to reconstruct position with high accuracy.
By the way, okay, I like your reference model generally. I think you've got the experiment, you've got the references, but I think your profit on top is way too high. I mean, it's not at the right level. I think here, robustness, size of working area, and robot cost, it would be accuracy of position of robot or something like this, right?
We have localization accuracy as measurement factor.
Okay, then the end there, what's the robustness, size of working area, and robot cost is the cost, maybe, okay, robot cost, size of work, what is the price, where is all this contributing to? What are you really trying to do? You're not trying to increase the profit of a company. You don't have a company, you're not testing in a company environment. What is the goal of your research?
The main goal is to increase size of working area. For example, that allow robot to work on highly, for example, in Skolkovo, and also increase robustness, increase accuracy of localization.
So I would say, I would propose to you that it might be applicability of robot technology. or coverage of robot technology because applicability in terms of how many people can use it. You know, it has to be done. It's not the profit. No, I'm sure you're not concerned about profit because to get the profit, you need to know the cost of, yeah, you need to know the robot cost, but you need to know how much money is coming in. And this is not what I think what you're trying. And I think it's very important that you find this, Michael.
Can I suggest something?
But this, yeah, I come back, Fernando. But this will help you to focus your research. Yes, Fernando.
So maybe he can join the three last black circles, and maybe he will have this endpoint by saying that he wants robustness and decrease this or increase the size of the working area and reduce the robot cost.
But there is a, yeah, you could leave them at the 3 too, or you find that the ultimate goal. But I think trying to find the ultimate goal in technical terms, will help you too. I think these 3 parameters are good. I agree with you, Fernando. I think that this is quite precise and it's good. But I think that, you know, yeah, so by increasing the robustness of solution, the size of the working area and the robot cost, I think obviously you're aiming for something very good, and then you have the technical. So I like that. I like that very much. But I think it's not profit. It's something else. Or you remove it, and then show me your impact model. Where are you gonna play?
Can you repeat your question?
Where is your show us your impact model? Do you have your impact model?
Do you see this impact model?
Yeah. So your impact model, so unsupervised 3D feature, your contribution is not well explained because it's not unsupervised 3D feature. It's contribution, because this is something that exists, right? Unsupervised 3D feature recognition. And
okay.
3D, is it an algorithm? Is it going to be a tool that's going to do this? So it's recognition or calculations or something like this, right? Yeah. Okay. I think probably at the top there is effectiveness of robotic solution in multiple environments. And this is what you're trying to do. You're trying with your solution, try to make the applicability of robotic solutions much wider. That's what you're trying. Less costly, more robust, and working on great areas. Well, that would be phenomenal if you're successful, by the way. Any other questions are for Michael? The only thing that you're missing is the plan. How long will it take you to finalize, to finish this?
I'm afraid to make a plan because as I said before, I have 3 stages of research, and I think that it will continue, but I go to pick.
But at what stage?
I think that I have 2 months for this hypothesis verification on the preliminary data sets. If I will succeed with this, I continue, and I think it took other 2 months to make make experiments on data sets and adjust parameters.
When are you hoping to defend?
Can you repeat your question?
When are you planning to defend your thesis?
2 years.
In 2 years, 2.5 years or 1.5
2
years?
and a half. 2.5.
Okay. Well, this is the plan to the end. I think it would be nice to see from now. It's not about the next 2 months. That's the big question on a research proposal, is how am I gonna get to the end of this? How am I gonna, start to write the pieces, finalize? Because I think you're starting to have some pretty good ideas how you're gonna do this to the end. And I think your impact model is, you're getting there. But now, how would you defend to the end all of this? Answer your research question and deliver the solution. It will not take 2 months. You will not defend in 6 months. That's for sure, right?
Yes,
Okay.
but it is a very difficult question for me to.
But you need to try to do something. Of course, it's going to change, but I'm sure you have some kind of an idea that in 6 months you will have that favor. I think you had another slide a little later. You had another slide. Show the next slide. Okay, yeah, see, you have. So you could put a date on your first descriptive study, a date on your descriptive study 1, prescriptive study, and descriptive. You could put a time frame, which probably will change, but at least you know you have to do it. Right?
But I think each step is several months. If hypothesis is true, each step is 1 or 2 months.
Or more than this, more than this.
But the problem is then my hypothesis is not true, and I need to redo this work
So
again.
you think that maybe unsupervised will never work? Is that
Yes.
what you're saying?
Yes.
And then you're going to go to a form of semi-supervised or
Or semi-supervised or more to structured based approach or standard coordinate regression.
so your research question is really focused on the short term.
Yes. I have a more general research question, how unsupervised methods can help to visual localization. And we have also unsupervised depth prediction. We have variational methods, which I investigated before.
Okay. All right. Thank you very much.
Thank you.
Any other question? So what I get from your work, so I think that generally it's pretty good. I think that your answer to question is good. Now, I think in terms of precision, it's just that you explain things, but this unsupervised versus semi-supervised, you look at that slide that you have in front of us, that leaves people a little lost on which one. But I understand what your hypothesis is, that unsupervised method will help you, but it's still an hypothesis to be proven, right?
Yes.
And third question is good. It's normal to arrive at one point or say, oh, we better readjust the research question because we're in a wall here. We're not going to be able to do this. Well, it's okay. It's okay. It's no problem. Any questions for Michael? No? Well, let's take a break. I suggest we take a 10-minute break, come back at 2 o'clock for the last presentation. Okay, thank you. All right, so Ibrahim, I guess are you almost ready?
Yeah, I'm ready.
Okay, let's go.
Can you see my screen?
Yes, we can.
Okay, good. So my name is Ibrahim. I'm a first year PhD student. My main PhD topic right now is about the power system stability analysis and control with large renewable power integration. It's a very broad topic, but I'm still like exploring it. So with time, I'm guessing it will get more specific. Just to give a background about the problem, we used to have around the world power grids that are traditional. They're called conventional powered by conventional power plants like nuclear power plants, thermal power plants, and hydroelectric. Nowadays, everyone, like most countries, are moving towards renewable sources. That would be solar power, wind power, and tidal power. This change in the topography and the nature of the power grid is what drives my research. So we can see that in Europe, for example, in the world, for example, since the 2000, there have been an increase in renewables. It's almost half the production of hydro, while at 1965, for example, there was almost zero renewable power around the world, so we didn't have to worry about that. This increase in renewable energy has provided some challenges. The use of renewable energy can be linked to cases of blackouts that happened through the last 5 years, like the Southern California blackouts, South Australia blackouts, and United Kingdom blackouts. As much as renewables can contribute these blackouts, they are not responsible for them. The mishandling of renewables was not helpful in these blackouts. They weren't a positive factor in these events. So that drives us to the problem definition. So why is there a problem with using renewable energy? To make it simple, conventional power plants, whether they be hydro or thermal or nuclear, use big generators. They are called synchronous generators. They are rotatory machines that provide the power, while the new renewable energy, they depend mainly on power electronics. So you have a very big rotation machine that is now being replaced with a small inverter that is providing power. That can cause multiple problems. For example, you don't have the inertia of the big rotation machine. You also have limitations on the current from these devices, given their small size and their power electronics which are rated for lower current. Another problem is that these power electronics can cause instabilities in the grid. So you have unstable operation in PV, for example, on the left. These are low harmonic oscillations in the voltage of the grid. You can also have the same thing in grids with high wind integration. So, for example, the right graph shows some oscillations in weak grids with high wind. Actually, these oscillations were recorded in the Texas grid. So these problems need to be addressed if we are going to securely operate power grid. So when I say securely operate, it doesn't mean that just maintain stability. It also maintains stability in the case of adverse situations. So in case of weather events, in case of faults, in case of, for example, generation malfunction. So these are all calculations that you have to take into account and to ensure that the power system will stay stable as possible after these events. So I can simply formulate my broad research question to be, how can we model that new power system in a way that takes into account the high inverter-based power sources and that the nature of the generation of being decentralized in order to arrive at concrete stability criteria and also to test proposed control methods. So we need new control methods to address the new problems. And we also need a platform to test or a model to test these control methods. There are also some research sub-questions that can be derived from the main one, like what are the most important parameters we need to study, because not all parameters are important to our case. So So in the case of high renewable integration, inertia plays a major role in integrating renewable power. So we need to first identify the parameters that we are going to emphasize on. Then we need to check what are the possible trade-offs between having a good model and having a hard to use model. So these models are not going to be used once and that's it. They should be used on day-to-day basis, because grid operators need to model the grid almost every day. So it can be a big model, but it also needs to be a robust model that performs its function accurately. And then we can explore control techniques that might work better with the new grid, which may have not been explored for the traditional grid, but they might perform a better function now. We can show this using the reference model. So the key success factor here, or success factor here, is the stability of the power system. This can be qualitatively measured. So we have, for example, N-1 criteria that the power system would be stable after the loss of one element. We have N-2 criteria, N-3. We can go all the way over to like N-10. We also have a key factor, currently have a key factor as the available system inertia. So there are other key factors that we might explore, like the size of the system, like the size of the power system can also be a power factor in the future. But right now we are focusing on the available system inertia. A measurable success factor would be the accuracy of system model. Measuring accuracy is a bit tricky. So if you are working with mathematical models, to measure the accuracy of a mathematical model, you need a more detailed model. And if the mathematical model matches the detailed model, then that's an accurate system model. You can calculate the error in the model. If we are working with detailed models, then we need to benchmark them against like hardware, and we implement the model in hardware and check for error in the results, and that's how we measure accuracy. Most of these arrows have assumption on it, because we're still in the literature review phase, as we'll see in the time schedule. As for the impact model, we hope to create a robust system model that will allow us to perform quality stability analysis. This quality stability analysis would open the way for using quality control methods and increase the efficiency of system operation. As of right now, having more inverter-based generation in the grid is being slowed down. For example, in Denmark, they have this problem that wind generation is reaching dangerous percentages that won't be sustainable. So we need to find solutions for that. And the success factor still remains the stability of our system. It's still a broad success factor, but it can get more precise with time. So in this research, or at least in the next 2 years, because I don't have a 4-year plan yet, I hope to deliver on a robust system model. So using either Simulink or BSCAD, that will highlight the problems with high renewable power integration. This is actually a continuation of my work in masters. There is also the development of real-time digital simulations in lab. This is when you use computer interface along with some hardware simulation to simulate like a real grid. I'm also implementing some control methods in hardware inverters. So, but in the lab, not in a company or anything. It's a lab settings inverter, but it can be developed for corporate purposes or industry purposes. These deliverables have a time schedule. It's loosely like hypothesized time schedule. It's for 2 years, so it's broken down into developing the model itself. Using this model, we can then go into control methods and design them. The hardware is a little bit independent, or like it's not very related to the other work. So it works on its own, or like it progresses on its own. Some of these things are done, like some of the literature review in the modeling is done. Sorry about the small font. And that's it. I think that's, if this is the schedule for next 2 years, I would be very happy if it's actually been will be realized. Thank you for that. Any questions?
You're not, Brian, thank you very much. I know it's quite early for you, but you don't mention the research gap. You don't have any, you know, what is not, I know there's been a lot done. Well, people are starting to work on but you don't, maybe it's too early yet, but do you see a research gap showing up?
Well, actually, I struggled with identifying a research gap for this. So the problem is there is not a gap per se. So let's say, for example, modeling the new system. So there are many models for the new state of the system, but the problem is each of them serves a specific purpose, at least in the research. So there are no comprehensive models outside of industry. Maybe there are some industry model or grid operation, like grid operators have their own model, but in the research there are no comprehensive models for the new state of the grid. There is also no IEEE standard, so we usually have a IEEE standard for interconnection. The current IEEE standard, the latest one, it doesn't account for the new state of the grid. So it's not a gap. So there is research on the topic, but there is nothing comprehensive on that ties everything together.
And how do you see concretely what you propose to do will prevent blackouts?
Will prevent blackouts. Okay, so preventing blackouts is a tricky business, I would say. So it won't prevent it. It would decrease the possibility. It will solve many of the problems that cause blackouts. So some of the blackouts are caused by miscommunication between, for example, the grid operator and the generation company. So the grid operator assumes some parameters that the generation company doesn't provide, and that miscommunication leads to blackouts. So I can't help that, like I can't help with that. But some other blackouts are caused by lack of understanding of how the, like, for example, wind power plant would behave in case 1 or case 2. So this lack of understanding is what we are trying to address.
Okay. Could you show the first diagram that you showed?
Oh, sorry, 1 second.
Yeah.
Okay, first diagram. This one?
Not the, no, the other one. Yeah, this one. You showed this hydro, the blue one as hydropower.
Yes.
I think it has hydropower, coal, nuclear, everything included there. No?
No. So this is just for renewable energy generation. But just as a note, hydropower is also synchronous machine, so it's not what we are concerned with here. But this is just to show that even like having hydropower as a renewable power, other sources like wind and solar are catching up. So it's almost half hydropower right now.
Okay, yeah. And okay, good, thank you very much. Any questions from other people, comments?
So may I ask a question?
Yeah, sure.
So Ibrahim, can you please go back to the impact model?
Yeah.
So please explain, what do you mean by the efficacy of system operation?
Okay, so system operators are responsible for like predicting the state of the grid. So there are multiple ways to, like, multiple stages of prediction. So for example, the grid operator decides how many units of generation will be online tomorrow and how many units of operation will be online the day after tomorrow. They have to predict how the grid will act, because it's not like it's not a static situation. What their prediction is, their efficacy of operating the system tomorrow will be. So if they make bad predictions, the grid will be in bad shape tomorrow. if they make good predictions, it will be in a good shape tomorrow. So there are multiple like ranges of predictions. So grid operators model or like simulate the grid for a day or 48 hours or a week. So having the right tools for this, to make these calculations simulation would help them better operate the system. Does that answer the question?
Okay, so are you sure that the efficacy is the best word here? Maybe it would better to call it effectiveness then.
Yes, I think effectiveness